Today we are going to discuss about rank of a matrix by normal form. Normal form is also known as canonical form. Okay. Rank of a matrix by normal form. Normal form. Canonical form. Normal form is also known as canonical form. Okay. Canonical form. And the matrix A of order m by n is said to be in normal form if by help of elementary transformation, either row or column, both row or column transformation, we can reduce it to any one of these matrix I R or I R 0, 0, 0. Here I R is a identity matrix or I R 0 or I R 0. Okay. If with the help of proper transformation, set of transformation, by reduce this given matrix and by n matrix to any one of this form, then this form is called canonical or normal form or canonical form. Okay, both are same, normal or canonical form. Where I R is the identity matrix. Okay, identity matrix of order m. Okay, now we will solve one example on normal form of a matrix. Find the rank of given matrix by reducing it to normal form. Equal to 1, 2, 3, then 2, 3, 4, 3, 7. We have to find out rank of this matrix by reducing it to normal form. That is, if I reduce it to any one of the equivalent form, IR or IR 0 or 0 IR, this is equivalent. Okay, this is equivalent, any one of these two, and this IR 0 or this is equivalent, IR or this IR 0, 0, 0. Okay, then this R is called, that is order of the identity matrix is called rank of the matrix. Okay, we have given this matrix with the help of proper transformation for row and column. In normal form, we use both row and column transformation alternatively. Okay, then the equivalent matrix is of this form. The order of the identity matrix will be the rank of the matrix. Now we are going to reduce it to any one of this form. 1, 2, 3, 2, 3, 4, 3, 5, 7. Then, first of all, check whether this element is non-zero or not. If this is a non-zero element, then it's okay. If it is zero element, then check whether I will get unity. If here there is no unity, then I take any one of the element here with the help of row or column transformation. Okay, here it is already non-zero and 1, so I will not do any transformation. I am repeating, if this element is 0, then we make this non-zero. If there is already 1, with the help of proper row or column transformation, make this element 1. Okay, here it is already 1, so I'm leaving this step. I'm not going to do any transformation here. This is 1, so this is non-zero. This is already unity. Now with the help of proper row transformation, I will make all the elements below this column, first column 0. So what are the transformation? Transformation will be, to make this 0, I will operate R2 minus 2 R1, R3 minus 3 R1. So this is 1, 2, 3, and this, if I do this transformation, then this element is 0 and trivially this is 0 by this transformation. Okay, this element is 0 by this transformation and this element is 0 by this transformation. I have to find out the remaining 4 elements by using these transformations. This element will be 3 minus 2 into 2. 3 minus 4 minus 1. 4 minus 2 into 3. This one. Then this is 5. 5 minus 6, that is minus 1. 7 minus 3, then this is 3. 7 minus 9. Now, with the help of column transformation, look here, I have started with row transformation. Then with the help of column transformation, I will make this element 0 and this element 0. The transformation to make this element 0 is C2 minus 2C1, and transformation to make this element 0 is C3 minus 3C1. This is 1, 0, 0, as operation is performed on second and third column. So these two columns with changes. Since these two element is 0, it does not affect this element, this element, this element, and this element. It will affect only this element, as this one is non-zero. So apply the transformation. It is straightforward. This is 0. This is minus 1. This is minus 2. Minus 1. Minus 2. Okay. Now, you can check it out. This element is minus 1. This element is minus 1. You can make it 1. Then it will be 1 plus 1. Then plus, add it to third row. You will get your, this element will be 0. Okay. I will move diagonally this element, diagonal element, and here it is a non-zero element, but it is minus 1. Here, by the intuition, I can say that if I subtract this R3 minus R2. R3 minus R2. R3 tends to R3 minus R2. So this will be 0 and trivially this is 0. So I am not going to make this one unity. Then I will subtract it from here. I will trivially perform this operation and make this one 0. So R3 times 2, R3 minus R2. So if I perform this operation, this one is 0, this one is 0. Then alternatively, I can make this one 0. At first I will make this one 1. Okay. This one will be 1 if I multiply C2 by minus 1. As my intention is to make this identity matrix, so make this 1. Then this is 2, 0, 0. Look here, to make it 1, I have to multiply this by minus 1. So this is whole column will be 0, 1, 0. Then with the help of this column, make this element 0. With the help of this element, make this element 0. With the help of proper column transformation. That is C3 times 2, C3 minus 2, C2, not C1. Okay, this is C2. Okay. Now you can look here. This is the identity matrix. Okay, this is the identity matrix of order 2. This is the identity matrix of order 2. Therefore, rank of the given matrix is 2. Rank of A is 2. That is, I have reduced the given matrix to normal form. In this form, I will get identity matrix of order 2. That order is the rank of the given matrix. Okay. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.